Hello. So I'm kind of changing up things a little bit. Obviously, I'm using OBS and I'm recording my face, which I normally don't do. And I feel like I'm starting to get more into formulas and stuff like that. And I definitely don't claim to be a math expert, but I do like math. So yeah, so today I'm just going to go over, basically, I'm looking this way because I'm checking to see if I have any water, which I don't, but whatever, it's fine. Circle formulas and how to basically kind of create a circle in SDL. And it sounds simple, but there's more to circles than you think. And there's lots of different approaches. As with a lot of things in math, there's a lot of different approaches. So I'm just going to open up Desmos, which Desmos is already open. So one of the standard forms for a circle, which we're not going to use, is, okay, I'll write out the formula. Hang on one sec. So the standard form is usually, it's, I think it's like x minus k squared, and then that, I think it's plus x minus h. I'm writing with my mouse, so the handwriting looks terrible. Squared equals the radius squared, right? And then k and h would be like the center point of the circle, and r would be the radius. Oh, I messed up this formula a little bit. It'd be y. So x and y. So yeah, k and h would be the center point. X and y would be where x and y would be if, you know, they were this whole formula was equal to r squared, radius squared. So if I punch that in Desmos, so if I do x plus, let's say we want the center point to be 0, and then squared plus x, oh, it's minus, I did plus. Not that it really matters because the center point is 0, but, and then do squared, and then equals whatever the radius we want to be, let's say 10, and then squared. And that doesn't equal a circle, so that means we did not do the right formula. I have it in my notes somewhere. It looks like I did do it right. Looks like it. Oh, I didn't do y here. Okay. Yeah, there we go. That is a circle. But the problem here is if I do this in code and I want it, like, from my understandings, maybe I'm wrong. If I want to get every x and y value, if I want to get the x and y value right, I have to kind of like scan through a whole, like, I have to keep scanning from, I don't know, like, from like right here, from this point to here, then I have to scan from this point to here, this point to here, to get, and keep going and scan all these values until I get the right x and y values, and that would take a pretty long time, and that seems like that'd be a very long loop, and that is something I don't want to do. So what we're going to do is use sine and cosine. So I'm going to pull up YouTube real quick. There's a visual I want to show everyone. Khan Academy circle. Trying to find the right one. Sine, cosine, visual. I think this is it.
Now I'd like to dip.
I don't want to hear your voice though. So, here. I want to see them both at the same time. So we're going to use sine and cosine. And this visual right here is a very good visual of what's going to be happening. So if we were to draw a regular sine wave, right? If we were just to use sine or cosine, the wave's going to look pretty similar to this, right? And that is not what we want to draw. So if we just did something like, I don't know, let me go into development. So if we did something like, let's say, hang on, what's this? Sec. I said ses. I don't know what a ses is. I almost said hang on one ses. Maybe I was trying to say second. So if I were to do something like this, and I'm going to explain this in a second here. Y equals sine x, right? So if I got my x and y values this way, I could times it by the radius. This is just kind of like pseudocode. Oh, thank you for. This is just basically pseudocode right here. But if I were to do something like this, you know, I could get, you know, this would basically draw a typical sine wave like this, right, onto the screen. And I actually, instead of plus plus, I'm going to do plus equals accuracy. How do I spell accuracy? That is definitely not how you spell accuracy. That's gotta be it. Accuracy. What is the accuracy of me spelling accuracy? Oh, I put 3 C's. I was like, okay. Okay, that's right. So this is gonna be some decimal point, right? And we're gonna keep adding, keep adding x. And when x is equal to this, then y is going to be equal to this, right? And this right here is going to draw, like I said, one of these waves, right? But it's going to start at the zero, and it's going to go up. So if you wanted to really see what this would draw, if I looked at an x and y axis, it would look something like, so it's going to start at 0, and then it's going to go up. Let's go down like this, and it's going to go up, it's going to go back down, you know, just like that. And depending on this accuracy, right, will determine how many points we have throughout the sine wave. And the lower the accuracy, the less points we're going to have. And obviously, a computer can only do so many points here. I can do this in a different color. So yeah, the accuracy is going to determine this. And yeah, you kind of get the point. These points. And there's a name for them, for these points, when it comes to like digital signal processing. I forget the name for them, but there's a name for them. Yeah, so as x increases in time, so x is basically time, right? So as time moves, these are the points we're making. So the x value, this is time, y value, so this is x, and this is y. Y value is like the amplitude, x is time. And if we want to make a complete, if we want to do a complete, so for sine, the sine function to complete a full, circle from 0 back to 0, it would be pi times 2. So what we're drawing is, we're actually going to end the drawing like right here. Oh, this eraser is not working. Oh, yeah, it is. I just have to let go. So we're only drawing, you know, this is 1 hertz, 1 sample of the sine wave. Is that the right word to use? Not sure, but if you measure from one point to the next, that's 1 hertz. So make, let's see, make your make file. Trying to remember. I think it's, no, that's not it. Star. I think that's right. Let's see if that works. Yeah, so and then libs equals and then this libs, this is any libraries you want to include, whatever. All right, so let's get SDL in here. H. Just make sure it builds. It does. And I'm making a source me file. Tmux. Just so I can have tabs here. So go back to that. Go back to where we were. Circle maps. So this is back where we were. And the source me file, I'm going to copy it from here. So basically when you press Control and Control P, right, you know, it looks up matches, keyword completion, right? So this looks through these libraries so that I can add these things to keyword completion. So if it finds definitions for something, for functions in these header files, right, then it will use that for the keyword completion. So yeah. So I'm just going to add that to here, just so that it makes things easier. So the foot watch, if I do SDL and I do Control N, it's not going to show anything. But if I add the source me, and now I do SDL, it shows a whole bunch of stuff. So that's why I did that. There we go. Yeah, it's a lot. So, you know, I was looking up how things work, you know, as I did it. But so anyways, what's happening is I created a window called circle of maths. This is the x position, this is the y position, this is the width, this is the height, and the x and the y are centered. And then this is the flags saying show the window. Then after I make the window, I create a render from the window. Then I set the draw color for the render, which I'm setting as black right here. And then I clear the screen, which basically just fills the whole screen with the draw color. Then I set the render again to red, then draw a line from, you know, where x and y is 0, 0, which is in the top left, to where x and y is 400, 400, which is right in the middle of the screen. Then I present what's in the render, then I delay it to just show it on, so the window doesn't disappear right away. Then I destroy the render, destroy the window, and then get out of SDL. SDL. So let's make our draw circle function. So I'm going to make it 400, 400, which is the center of the screen. Draw, circle, center, render, center, and then the radius, make it 10, not 100, not. What's wrong with this? Oh, wow. Just for some verification there. Let's see what happens. So yeah, obviously it didn't draw a circle, but it drew what we were just talking about. It's really small, but it's drawing this, like I was talking about, and it's trying to put it as close to the center as it can. And I know I put this x1 plus center x, and it's still not going to be 100%, you know, accurate. Sorry about the audio in the background. Someone's watching TV. So yeah, the issue with that is, like I said, it's displaying it over time. So we could, if I take the radius up, I'll show you. It draws it a little bit bigger, but it doesn't really stretch it over time. So with what we have now, if the accuracy is at a certain point, right, it's gonna look like this, right? And you know, there might be a little bit above. So here's tau, right? It might go a little bit above, but it's really fine, because in a circle, you know, if I draw a circle, right, and I stop here, and I add a little bit extra right here, it's not going to matter, because it's still going to, the same circle is being drawn. Once I keep going around, once I go past 360, it's not going to draw anything different or change how it looks. So it's fine to keep it that way once I go past 360 degrees. But right now, obviously, it's not a circle. So let me go on the point of fixing this to make it a circle. Going back to this, sine starts at 0, like I've been showing here, right? Like this is the starting point. It starts at 0, and then it goes like this. Cosine doesn't start at 0. It starts at a different point. Cosine, let's say this is 1, this is 0, this is negative 1. Cosine starts from 1, goes through 0, and goes back to 1, like that. Well, I mean, it's going to be a little more curved. It's going to look more like this, right? So it's going to look kind of like a weird U-ish shape like that, right? So I can show you that actually right now. So if I do cosine instead of sine, it's going to be really small again, but... And it looks like it's the other way around. Like it's starting at negative 1. Strange. Yeah, it looks like it's starting at negative 1. Yeah. So, yeah, for this example, it's kind of like starting at negative 1, going up, and going back down. It's strange that it starts at negative 1, but it's fine though. But that's what it's doing. It's basically, yeah, it's starting from a different point. It's the point I'm trying to make. And if we, right, like this image kind of shows right here, right? Yeah, so this is the x-axis right here. This is sine. You know, starting from 0, going to 1. In this case. Yeah, sine starting from here, going to 1, going to negative 1. You know, this grid doesn't help make it clear. Just ignore the fact that this is a grid, because I think this grid is being represented with complex numbers. So just don't pay attention to the grid. Just imagine like this is 1 and this is going back to negative 1. This is 1 and this is going to negative 1, right? If you followed my mouse cursor, I hope that made sense. So this is sine going along the x-axis. This is cosine going along the y-axis, up and down. Plus plus quadrant. There's names to it, but whatever. X is going to be plus, y is minus. Then we have both minus. Then we have negative plus, right? So then we have, for the x-axis, we have sine function and for the y-axis we have cosine, and I is like just an increasing number, right? So when you're between the range of 0 through 1, 2, so when you go from these, so when you're at the point 0, 1, which I'm going to say right here, it's this point, and then you go from 1 to 0, which is this point, and you go between those ranges, right? Sine and cosine will be both plus and minus, right? I mean plus, the x and the y value for sine, so sine and cosine, which are saying this is sine, which is the x value, and this is cosine, which is the y value. They'll both be in positive ranges, like they should be. Now when you're at 0, 1, which we're going to say is right here, and then we go from 0, 1 to 0. No, I said 0, 1. So let's say this is, whoa, this is 1, 0, right here, this point, and this is 0, negative 1. When sine and cosine x, y are between these ranges, then, you know, sine, which is the addition, sine is positive, and then cosine, which is y, is negative. And then when you're, I'm just trying to make this crystal clear right here. Then when you're at the points, this is supposed to be an arrow. It's kind of a poorly drawn arrow. So this is 0, and then y is negative 1, so that's this first point right here. Then you go from negative 1 to 0, which is right here. Right, from these ranges, from 0 to negative 1 to negative 1, 0, sine is negative, and cosine, sine, which is x, is negative, cosine, which is y, is also negative. And when you go from, I hope you're getting the point now. From negative 1, 0 to 0, 1, then sine is negative, and then cosine is positive. So that's why setting sine on x and cosine on y would make a circle like this. And then obviously after this it would go back to the beginning right here. And it would just keep going if we let it keep going. So let's kind of like create that. Go. All right. That's the point. And there we go. That drew a circle. Boom. So this is kind of addressing what we just talked about, right? And so we have sine for the x, and I explained why that is. Sine for the y, right? And then I set x1 to the previous x, y1 to the previous y, and then as long as I is greater than 0, if I is not greater than 0, continue. That's because we need to set the current value and then the previous value, so that's why I do that. If the current and the previous value aren't set, then why draw the line? Yep, and then I just draw x1, y1, a point from x1, y1 to x2, y2. Then I just add, the center point, to offset it so the position needs to be. And then I'd multiply it by the radius, because if we have a value from 0 to 1, right, and we times it by the radius, it's going to scale that. So we're just scaling it right there. And if I make this a little bigger, let's see that I can make my circle a little bigger here. And if I want to make it like the size of our window, I could do 400 and it should just fill in the whole window right there. So there's a lot to this video because I didn't want it to be, you know, just a simple explanation of why this is happening. I wanted to kind of go into detail, you know, a little bit. So yeah, and then if I set this down, watch, this is not going to look, see how the accuracy went down? Now it looks almost like a, I don't know what, like a hexagon. I don't know how many points are in it, so I can't say if it is a hexagon, but I set the accuracy a little lower right there, but you can't really tell that much. See, and then I keep going lower and lower. It starts to look less and less like a circle the lower I go. So, yeah. Yeah, that's about it for the video. It's a lot longer than I thought it was. Hope you enjoyed.